All right, watch this. This is going to be really, really neat. All right. Now, we're going to look at some derivatives now of quadratics. Now, as we're doing that, let's just consider first y equals x squared. Okay? So f of x equals x squared. So you got your picture here. It goes something like this. Okay, let's talk about what we expect the derivatives to be. All right? So let's look over here. You have right here a slope that's pretty steep, right? And then as you move, what's happening to the slope? It's becoming less steep, right? So it's still negative. It's just less negative than it used to be. And right here at 0, 0, what should your slope be? Well, it should be 0 because it's negative here and it's positive here. So somewhere in between, it's got to be 0. And where else but right in the middle? Okay, then we continue. Now the slope is positive and increasing. And then as we get here, it's even steeper. It's still positive, just more positive than before. So if I were just to put magical numbers here, maybe it went from -2 to -1 to 0 to 1 to 2. And these numbers are not right, but you know, the slopes are still negative but decreasing in value to 0 and then increasing in value. So something like that, right? Okay, so let's actually do this. I'm telling you, this is going to be awesome. So let's go ahead and do the first derivative. Now, before I do this, let me preface this by saying I know some of you are going to start to recognize patterns, and that's wonderful. Patterns are great. Mathematics is built on patterns, and the patterns will make this a million times easier because you won't necessarily have to do this fundamental definition by of derivatives, by first principles. However, you need to know how to do this because sometimes on the IB exam or AP exam, they will specifically say, find the derivative using first principles. And so you have to be able to do it to be able to get those points. All right, so let's do an easy one first. Let's take f of x equals x squared. Okay? F of x equals x squared. So let's go. Limit. So I'm looking for the derivative function. Limit as, not x, as h approaches 0 of f of x plus h. So x plus h is replacing the x. So it needs to go right in there for the x. So it's going to be x plus h squared minus f of x, which is not f of x. It is, of course, x squared all over h. All right, so let's work that out. Don't you dare distribute that squared. You distribute that squared, I'm going to walk over to your house right now and smack you upside the head. Yeah, don't do that. So we have to write it out. It's x plus h times x plus h, unless you know the little formula shortcut, which is fine too. It'll end up giving you x squared plus 2xh plus h squared. And then we still got the minus x squared there, all over h. Now you'll notice that the x squared and minus x squared go away, which will leave us with the limit as h approaches 0 of 2xh plus h squared over h. This can be factored, so limit as h approaches 0 of h times 2x plus h over h. You can now cancel out the h's, leaving us with the limit as h approaches 0 of 2x plus h. Now, of course, as h approaches 0, now I'm going to do the limit. That goes away. So the derivative of that function leaves us with 2x. Because h doesn't affect the 2x. H affects h. So 2x. So therefore, the derivative of x squared is 2x. Now let's make sure that that makes sense with what we talked about before. Okay, now not the actual numbers, but if I put a negative number in for x, right, let's say I put in -2, then I'm going to get a slope of -4, which makes it pretty steep. Okay, if I put an x value of -1 in, 2 times -1 is -2. So that means still negative, but it's less steep than it was before. If I put 0 in for x, that would be 2 times 0, which is 0, which means at 0, I got a slope of 0. And if I put positive numbers in, I get a positive slope. And the slope is always changing because as x changes, the derivative will change, and therefore the slope changes. Now, if that isn't cool, I don't know what is, because I just think that's cool. Now, this video is going to be a little bit longer than 5 minutes because we're going to do another one. All right? We're going to do one that's going to take a little bit longer because we're going to try now f of x equals x squared plus x minus 2. All right? So here we go. Derivative equals the limit as, I don't need that, as h approaches 0. Now remember, first is the f of x plus h. So I got to put x plus h squared plus x plus h minus 2. And then we will go, so that's the f of x minus h. So now we go minus f of x, which is x squared plus x minus 2. Please, again, remember to put this in parentheses so that you remember to distribute the minus to everything. This, of course, is still all over h. We'll go ahead and work it out. So I'm not going to keep writing that, but I will keep writing the limit because otherwise I'll forget to do it later. X plus h squared is x squared plus 2xh plus h, oh, that looks familiar, plus x plus h minus 2 minus x squared minus x plus 2 because I distributed all over h. Now this looks like a mess, and it is, but when I take the limit as h approaches 0, let's see what we can cancel out right away. Well, I got a minus x squared and an x squared. I got a plus x and a minus x, and I got a minus 2 and a plus 2. So a lot of it's going away. So I'm left with 2xh plus x squared plus, plus h squared plus h all over h. Let's factor out the h. So when I factor it out, I got h times 2x plus h plus 1 all over h. We will cancel out the h's, and because I'm feeling like I'm running out of space, then we got 2x plus h plus 1. Note that as h approaches 0, this h goes away, which means that the derivative is 2x plus 1. There you go. That is your derivative function. And now you can take any value for x, you can put it into x, and you can find out what the slope is at that point. Again, if that isn't cool, I don't know what is. So anyway, what I'd like you to do now is I'm going to put one more up here since I've already gone over my 5 minutes. I'm going to go ahead and put one more up here. Then I want you to try it. Okay, so I got f of x equals, let's go 2x squared minus 3. All right, so I would like for you to do this one by first principles. Don't use any sneaky tricks. I know there's sneaky tricks, but I want you to figure this one out on your own. So try this one. At 8:30, 8 minutes and 30 seconds, go ahead and pause the video because after that, the answers will magically appear. Ta-da! So there you go. You now see that the derivative function of 2x squared minus 3 is 4x. So with this, you can now find the slope at any point on this graph, which remember this graph looks, it's stretched, it's been shifted down 3 spaces, so it looks something like this, and it's really skinny like that. And you could now say, oh, what's the slope at x equals 3? And you could put 3 in and you say, oh, the slope is 12. Isn't that cool? Anyway, so there you go. You can now find the derivative, all right? I think I got one more video. Why don't you go watch it?